Hello everyone and welcome to part 5 of Python programming series. This is Ram Prasad Pujari. When you install Python, then you have access to a large number of components. Now what are these components? Some of them I have listed here. These components include built-in functions. We are already familiar with built-in functions because in the last previous sessions we discussed about built-in functions. And you also have access to built-in constants like true, false. These are all the built-in constants available, which is part of Python standard library. There are even some modules which are available. Today we'll focus on these modules, and we'll take one of this module, and then we can discuss about that. Like every session, we will have a laboratory session. I'll be using Jupyterlab to test these functions. The previous sessions we discussed about built-in functions and how user-defined functions are created. If you have not watched previous videos, kindly watch them. So as I mentioned, today's focus is on Python standard library, which comes with your installation. It has got thousands of various components that are available free to use, and we are going to pick one of the component from this, that is numerical and mathematical modules, and we will try to understand what these modules is all about. As you know that this is like a built-in function. You have a module. Module is basically a collection of maybe functions or constants, variables, etc. And we are going to talk about math module here, and even there are other modules which are available, and how you can create your own module, that we are going to see in the future sessions. But today we will focus on the math module. What is math module, and what are the functionalities available under this module? So that we are going to discuss. But the standard library also has other modules which are listed here, but we are not going to discuss in this particular session. So our focus is on math module. As the name indicates, math module is used for performing mathematical operations. Maybe if you want to compute maybe a sign of a given variable, or maybe you want to take a log of a given variable. So you have functions for doing this. Now we are familiar with Python functions and how you can create a user-defined function. We also saw built-in functions in the last session. But what is a module, or how you can create them? Just to show how a module looks like, I'm taking an example of a Fibonacci module. We are not going to talk about these statements, and I'll not be explaining them, but how a module looks like. Module is basically, you can think of as a Python script. A name is given. Let's say this is the file name, fibo.py, and this particular file will have maybe a group of functions. As you can see here, this is one function and name is fib, and there is another function with the name fib2. So there are two functions in this module. So module can be created by just creating a script file, and you can give a name to it. That becomes a module name, and within that you can put several functions or maybe a constants, etc. Now this Fibonacci module will have two different functions, and you can use them like this. We are going to see some examples for this. As I mentioned, today we are focusing on math module, and these modules are written in C program, and you can use them here freely, and no need of separate installation, this is part of your Python installation. And under this you have several functions for different for example areas like numeric representation. We are going to talk about these three functions, and similarly power and log functions. You have three functions here, And similarly, there are some constants like pi, e, and infinity. So this is exponent. Trigonometric functions and angular conversions. So we are going to look at these functions today. Under numeric representation, you can use math.floor function. So we are going to understand how these functions work. So we'll have a demo session now. Okay, so let us start using the math module. And very first thing that you're supposed to do is to import math module into your program. So this is the command to be used, import math. And then you can run this cell. You can also press shift enter for this. And after that, once you import math module, after that you can use any of these functions. So let me start using the functions under numeric representation category. So very first function is a floor function. And remember, since the name of the module is math, I'll have to use a prefix math before the function. So math.floor will be the function. This is how you can call a function which is inside a module. So let me just start computing floor of 2.3, and as the name indicates, the floor will round off the value, round off 2.3 to a nearest integer which is less than or equal to 2.3. So I'll get 2 in this case, as you can see. So this will give me an integer which is 2, which is less than 2.3. So there's another function called as ceil. The ceil will also round off the value, but this time it's going to round off to integer which is more than 2.3, more than or equal to 2.3. So I'm getting 3 in this case. So this is the second function that you can use. You can also save this particular value in a variable, and then you can modify it. So next function is a factorial. As the name indicates, the factorial function will return a factorial of a given variable. The factorial, let me calculate the factorial of 4. So factorial of 4 will be 4 into 3 into 2, which is 24. So let's move on to the second category, so which is power and log functions. So I have listed 3 functions here. There are actually more functions, but I have listed only 3. I'll be using only 3 functions in this case. So math should be the prefix used for all the functions. Very first function under power and log category is log base 2. This is how you can use. And let me calculate the log base 2 of 8, which is nothing but 3. As you can see, 2 to the power 3 equal to 8. And similarly, log base 2 of 16 will be equal to 4. So I can also compute log base 10 of a given number. So let me calculate 100, which is equal to 2. You can also calculate the square root of a given function, given variable. Let me calculate the square root of, let us say, 25. And that's going to be equal to 5. And you can also initialize any variable. Let me just initialize a variable x equal to 36, and I can calculate the square root of x, and then this value can be stored in y equal to math dot square root of x, and then I can display y. So that's going to be equal to 6. So this is about power and log functions. And under math module, you also have some constants like pi, and for exponent value, that is natural log 10 to the power e. And similarly, you also have infinity. So let me just save pi by 2 in theta, and for that I can use math.pi by 2. So math should be the prefix in all the functions. So math.pi, which will give me pi and by 2. So I'll just say pi by 2 in theta. So theta will be displayed, it will be returned in radians, as you can see here. And similarly, you can also you can have a constant here. You can use this constant in your program by using math.inf, and you can save it in another variable if you wish. So that's about the constants. There is another category to compute trigonometric functions like sine, cos, etc. There are multiple functions, but I have only listed 4 of them. You have a trigonometric functions, that is one category, and then angular conversion also you can do. Angular conversion means you can convert any theta value into degrees from radians or radians to degrees. So this conversion can be done by calling these functions. So let me try these trigonometric functions first. I already have a theta which is pi by 2. So let me start using this theta and calculate sine of theta. So math dot sine of theta. So theta is pi by 2, so I should be getting 1 in this case. As you can see, I'll get 1. And if it is, this is pi by 2, so let me just say it's into 2 means, for example, let's say calculate cos. So it's going to be theta into 2, that's pi, and the cos of that is going to be minus 1. As you know that cos pi is minus 1. So math is the prefix again used if you want to compute cos or sine of a given variable. Similarly, let me convert radians into degrees. So as you can see, theta is in radians, 1.57 for pi by 2. So let me convert that into degrees by using the function math.degrees of theta. So that's going to be equal to, math.degrees of theta. So that's theta will be equal to, let me just calculate this. Okay, math.degrees of theta. So that's equal to 90. And similarly, let me just save it in some of the variable a. So a is 90 degrees here. So I can convert I can use math.radians to convert a, which is in degrees, into radians. As you can see, this is converted into radian. So this is how you can use different functions which are listed under a module, which are defined under a module. So math module has more than the functions which are listed here, but because of the time constraint, I am taking some of the important functions here. In the next session, we will see how we can create our own module. Okay, so here it is a built-in module. We can also create our module, or we can also use the external modules in our program. So for this session, this is all, and we will meet during next session. Thank you.